Hello everyone, my name is Rafidal Muhammad, private teacher at Neo Edukasi. In these micro-teaching videos, I'm going to explain briefly about differential in mathematics and its application within physics. I'm going to explain it in English, but I'll also put subtitles both in Indonesia and English to make it easier for everyone to understand. Okay, so see, students have lots of subjects in their school studies, which makes most of them take shortcuts by memorizing equations rather than to understand the concepts. For me, I believe that understanding the subject is actually making it significantly easier to understand and easier to memorize. It also makes the subject more fun because you actually know what you're doing. Let's start from here. Here is a common formula for derivative. If we assume that y is a function of x, y equals x with the power of n. So the derivative of y is n times x to the power of n minus 1. Here is the example of these equations. 3 times x to the power of 2, the derivative is 6 times x. While x to the power of 7, the derivative is 7 times x to the power of 6. But what it's actually do? What are these equations are actually significant in real life application? Why we do it this way? That's what we want to know in this video. The way I like to approach it, think of derivative as a slope. Let's imagine a ladder at rest on 4-meter wall. The distance between each bottom is 2 meters apart. The slope is equal to the ratio between the height and the distance from its starting point, which in our case is 2. The slope of this graph is increasing if the wall is higher or the distance is shorter, and vice versa. That's how we define a slope. But how about a quadratic or polynomial equations with curved graphs such as these? Well, as you can see with the curved graph, the slopes are changing with time. So instead of the ratio between the height and base distance from initial value, the slope is defined by the ratio between the height and base difference. We can make the difference between these 2 points, but it's less accurate because the slope between these 2 points is changing. We can see that the slope is different. We need to make this smaller. The way we solve it is using derivative by making this point infinitely small, closer to each other, where the difference is closer to 0. If we derive the equation from this logic, if we assume y is a function of x, with y equals a times x to the power of n, the ratio equations will be that y minus this y divided by that x minus this x. This right here is how we write the ratio equations. The terms d represents the difference, a value so small, close to 0. We can calculate. For numerator, we expand the polynomial, and for denominator, we eliminate the x. We take the two first polynomial from the bracket, which divides our equations into 3 parts. The yellow one cancel each other's out, which make it 0, while the green one is being multiplied by 0. Now, we're left with only one part of the equations, which is the original equations of derivative we all know, n times a times x to the power of n minus 1. So this is the reason of why we calculate derivative the way we always do. Its calculations were derived to make it easier to find the slope of a curve. But why is this important? Besides to find a slope, does this concept matters that much in day-to-day applications? I'm just gonna show it, the answer, by this physics equation right here. This is the equation of motions. The equations that all high school students should have heard in their 10th grade. This equation describes the relation between displacement, velocity, and acceleration. If we see and compare it to another equation, we can see that these two equations share some similarities between these. These equations are actually derivative, but instead of x and y, it's time t and displacement s, where s0, v0, and a are a constant. This goes to show us how these disciplines are actually correlates to each other. Scientists back then created these complex ideas for something. They create it for a reason. In fact, one of the people who popularized the use of derivatives are Isaac Newton himself, the same person who we know for his contribution in describing equation of motion using Newton's laws such as these. So, how do you think? Do these videos are actually helping you to understand mathematics? Or there is something else you want to know? If you have, you can contact us by links in the description below. Thank you for your attention and stay curious.